And that is a huge challenge. Every fire inspector and fire marshal I've talked to is not too keen on lithium ion batteries on top of their buildings.
Welcome to Hangar X Studios, where former fighter pilot and host John Ramstead takes us on a journey across aerospace as it enters an historic period of innovation and transformation. Our guests include aviation experts, pilots, financiers, military leaders, and innovators of all types. Buckle up for another episode of Hangar X.
All right, welcome to the Hangar X podcast, where we explore aviation, innovation, and everything VTOL, and a lot of the advancements right now that are affecting all of us. And today we have Rex Alexander on. Rex, welcome to the podcast.
Thank you so much. I greatly appreciate you guys inviting me on.
Well, it's so great to have you here. 4 decades of military aviation, commercial aviation, and you sent us some incredible pictures of you doing some testing in a Russian helicopter. I want to hear more about that. That looked like some really incredible equipment. And now as we're actually moving into this world of EVTOLs and VTOLs, infrastructure is a huge topic of conversation. And if you are having that conversation, I'll guarantee you, if it comes up, the name Rex Alexander is front of mind, because Rex, you are probably one of the foremost experts in this space. I was actually going to read your bio because you're part of helicopter safety team, vertical aviation safety team, technology working group, and I mean on and on. You're part of basically any organization, private, public, that's doing work in this area. You're a leader and a voice in that group, and we can go through some of that. But I'd love, before we get into the infrastructure piece, share a little bit about just your background in aviation and as a pilot, and some of the great stories you were kind of referring to before.
No, I appreciate that. Always had a passion for aviation. I always tell people, I said I took my first flight when I was 3 years old with my father, and was hooked ever since. It was one of those discovery flights at the local airport. You paid a penny a pound. I was a whole lot cheaper to fly then than I am now. But after that, I started taking lessons when I was 14, and then went to college, got my degree in aerospace or aeronautics in aviation maintenance and management at Parks College at St. Louis University. Wound up working at McDonnell Douglas on F-15s and 18s and the Harrier jump jet for a little while. A buddy of mine went to the Army recruiter and drug me along with him. And the next thing you know, I'm putting my right hand up and joining the Army because they offered me a flight slot. So I wound up in the Army and became a pilot, Aeroscout pilot, and an Aeroscout instructor pilot. And then later in the Guard, I was a standard instructor as well.
What helicopters did you fly?
I was old school. I'm old, so OH-58 Alpha Charlies before the OH-58 Deltas came out with the balls on top.
Mm-hmm.
We always said we did more with less than anybody else on the battlefield because we were using radios, one over 50,000 maps and compasses before all those electronics came out. So my job in the world as an Aeroscout pilot was to go find the bad guys at night under night vision goggles while flying through the trees and then blow them up. And we were really good at our job. Now, I never saw combat, but a lot of my friends who I worked with and trained did. So, but for whatever reason, all mine was peacetime.
And then when you got out, you got into commercial aviation also?
I got out of the Army, came back to the U.S. I had 2 jobs lined up in the Gulf of Mexico back in about 91, and the oil industry tanked, and both jobs evaporated into thin air, and so did every other job on the block. So I wound up, luckily, within 5 days of coming back to Indiana, I joined the Indiana National Guard because I was an instructor pilot and they needed one. So that was great that I could continue to fly and work in that space. And I took a job local. I worked for a friend in the Guard building signs. We did neon signs, electric signs. I was as an A&P mechanic, I knew how to weld and do all kinds of things that he found very helpful. So that held me over until I wound up getting a job in the offshore oil industry. About a year later, I worked out of Galveston in the Gulf of Mexico for about a year, and due to the relationships through the National Guard, one of my friends there had put me on to a job that opened up in Indianapolis where I lived for flying EMS. So I'd interviewed and took a job as a helicopter air ambulance pilot in, I interviewed in what was it, February of 91, took the job. I want to say it was probably July of 91.
So, Rex, I've been the beneficiary of a life-saving life flight. Terrible accident. I was in the hospital for 2 years.
Oof. I'm sorry to
But
hear
just
that.
quickly, when you're flying into an unknown situation, unknown landing field, right? You know that your time in, getting the patient loaded and getting back quickly. What are some of the things that are just that you're going through your mind as a pilot in that environment?
Yeah, I hate to say it, but I have this degree of doubt in that everybody is trying to kill me. And with that, everything is always being double checked no matter what anyone says. So when you're coming into the scene, you're always double checking the weather. Where are the winds at? Who are you working with? Where's the other traffic at? Once you get to the scene, you're looking at the landing environment. You're always looking for wires because there's always wires. That's just a given. We always, said that there's no such thing as no wires. Then you're looking for where the accident's at. Then you're looking to see, okay, what kind of accident are we dealing with? Is there hazardous materials involved? Is introducing the aircraft going to cause harm or danger to anybody on the ground? Do I need to step the landing zone off of a couple hundred feet? Or if, hazmat situation, I may have to step it off a quarter of a mile or more, depending on what it is. So in that space, we're always looking for the what if that can kill you. And once you're on the ground, you're always head on a swivel. I had my helicopter attacked by a bull one time. That was interesting. Luckily, the first responders were able to get it away from the aircraft before it, put horns into
I
it.
think the bull would have won.
I think the bull would have won. I landed on a rattlesnake once, got out, found that like really close. I've landed on highways at 2 in the morning and people don't pay attention to first responders and drive right around them and underneath your turning rotor systems. Yeah, it can get exciting. And then, like today, it's here in Indiana, it's 5 degrees. So you go out at 2 o'clock in the morning, it's, negative, and you don't know what you're going to go after. You might be on the scene for 7 minutes. You might be on the scene for, I think the longest I've ever been on a scene was 5 hours. That was a trench cave in and it was cold and we were there for a long, long time. So you have to dress for that. So you got to be prepared for anything. And then you show up and you're like, well, yeah, we're going to have to go by ground. The patient's beyond our capability of moving either because of their stature or because of they're so compromised. Or in some cases, we've had to move them by ground because they got stuff sticking out of them we can't put in the aircraft. Or hazardous materials are also you can't decon them enough to put them in the aircraft fast enough to meet the need of the medical situation. So it's constant. And
That's interesting because, as a pilot myself, right, those challenging environments are fun. You're always challenging yourself. And now I'm just curious, though, all that flying, instructing, flying out to rigs, flying EMS, but then this transition to infrastructure where now you've become a world expert. There's a passion there. You've developed leadership. What led into that transition to what you're doing now?
So I got out of military and offshore work, and there was a standard most people followed to some degree. I got into the aeromedical industry, and I was like, after 6 weeks, wondering why all the architects and engineers are out to kill all the helicopter pilots. And it was most people in that world, great people, they just didn't know what they didn't know, and they're eyeing this piece of property as a two-dimensional piece of concrete, not thinking about the airspace, not thinking about power lines. People love to plant trees around heliports. One thing about trees, they grow. And the next thing you know, you have 50-foot obstacles surrounding your heliport. I landed at places that I was like, where did you get those lights? Oh, they're pool lights. I said, you do know that there's a criteria for that, right? It's like you'd land and be blinded by this stuff. And you're like, okay, I think we can do better. I've seen every kind of marking at a heliport known to man. And in the beginning, few were right. So I started working with hospitals just to educate them on what it was supposed to look like. Next thing you know, my name kind of got passed around. to other hospitals, and I started charging. It was a part-time gig, and the part-time gig I did for quite a while, and then it turned into almost a full-time gig. I started my own company. Oh Lord, that was probably about in 98, 99. Then I went into partnership with a good friend of mine, Ray Sims, and we formed Heli Experts International. And shortly thereafter, I quit my day job, and we were working the partnership full time. And after that, one of our clients wound up being Uber Elevate. I'd met Mark Moore, who was from NASA at the time, helped write the white paper for Uber, and asked us to help with the infrastructure. And about a year later, next thing I knew, they hired me, and I was internal. I was an Uber employee. Then for the next year, I worked for them, and then started this company. And yeah, been doing traditional heliports all that time, but now I'd say 50% of our work is in vertiports and advanced air mobility and the R&D for that.
Yeah, I know your company, 5 Alpha. You're also a consultant advisor at a Vertical Flight Society. We just had them on the podcast, and I mean, your expertise is so needed right now. There's a lot of questions I have, but first of all, you know, as the FAA is coming out with more SFARs on powered lift specifically, and we're looking at, you know, a whole new capability with EVTOLs, with the VTOL we're building and things like that. What is the regulatory environment currently, and what does it really need to be able to allow the development of vertiports and really a whole new air traffic control system that's beneath the commercial part, you know, 35, 121 today?
All right, that's a lot to unpack. I'll start with the regulations. Regulations and guidance in the United States first. So the FAA has been doing a really good job. I've been working with them quite a bit since they started this. Mike Hirschberg, who is the former executive director for Vertical Flight Society, the one that brought me on to be the advisor.
Yeah, that's who we just interviewed.
Yeah.
So he'll be coming out soon.
So Mike and I actually met with the FAA back in 2019, talking about infrastructure and advanced air mobility, and kicked it off then, and been working with airports division in the FAA ever since then, helping to develop what this vertiport standard is. Been working with all the different players in industry to put comments together to provide feedback to the FAA, and we've been pretty fortunate. They've paid attention to most everything we've you know, discussed, and there's a big shift in there, which I'm happy to see. Is I got asked all the time what the question was, what's the difference between a heliport and a vertiport? And I would say, I said, one spelled with an H, one spelled with a V. I said, you know, in the grand scheme of things, it's all about the geometry that fits the aircraft and the airspace that provides the forgiveness necessary to do operations in a given day under all circumstances. So beyond that, it's pretty much the same. So I was really happy to see that in the last Engineering Brief 105 Alpha that was just published the end of last year, that they now said that vertiports are a classification of heliport. So it will take Engineering Brief 105 once it's been updated the last time, and they will then incorporate that into the advisory circular for heliports 1505390-2 Delta. So we'll see 2 Echo probably the end of this year.
How do you see those evolving over the next year or two?
It will be interesting. I think there's a player that we're trying to see how things move in that space, and that's ICAO, the International Civil Aviation Organization. They're having ongoing meetings. They have a working group for vertical flight and vertical flight infrastructure, and I see the FAA really having you know, a positive influence on those discussions. But right as of right now, ICAO doesn't have anything published for powered lift infrastructure other than their Annex 14 Volume 2 on heliports. YASA had come out with some guidance. A lot of that was copy and paste from ICAO's heliport documents. I'm not a big fan of some of the airspace that they propose because in my opinion, purely my opinion, it doesn't provide the forgiveness necessary for infrastructure. So we always say that pilots don't always have good days. Aircraft don't always have good days. You don't always have a good weather day. Some days, all three are against you, And you need to build a certain amount of forgiveness into your infrastructure. So when that happens, you have options built into the system.
What's the forgiveness that you're talking about?
So when I look at the infrastructure and the way we design heliports today, we're looking for clear approach departure paths. We're looking to make sure that we're not putting the aircraft in a situation that's requiring a significant amount of power. So we're using as much efficiency as we can at a slight approach departure angle. So when we design airspace for a heliport, it's an 8-to-1 ratio. So for every 8 feet you go horizontal, you come up 1 feet, which is 7.125. So a standard approach for a helicopter is 8 to 10 degrees. Steep approach we look at is 12 to 15. I looked at what YASA came up with, and it's basically a vertical descent once you get to the pad. And in that vertical descent, you really don't have the capability to fly away as easily as you do in a normal approach with the airspace. You really need to have that escape route when things go south. And I've had to use those escape routes on occasion due to winds and turbulence in downtown areas. I've had Mother Nature kick me in the butt several times. And luckily the heliport was such that I could get out of it without bending a skid.
So if I'm understanding you right, you want to design it so when I'm coming in on a normal approach, I have as much forward velocity as I can safely have before I have to come in that final flare versus having to come in, hover, and lower down in.
There's a lot of things going on there that I look at. It's like, we always have that discussion. It's like, yeah, you can do vertical, but why would you want to? I said, the efficiency factor is terrible. I said, you're burning 10 times more energy in the vertical than you are in the horizontal. So if you can maintain an airspeed that allows you to fly as efficient as possible, what's that do? Well, that extends your range. That also increases the capacity for you to carry another passenger or a couple more baggage. We don't teach pilots vertical operations in the civilian market. We do in the helicopter industry and in the military, because we do out-of-ground effect hover for checking before we go nap of the earth. That's not a procedure right now in the civilian market. And you can't see where you're going if you're going straight down. I don't know yet what the visibility looks like out of the cockpits of these aircraft, but I have a feeling it may be a little bit more restrictive than that of a helicopter. So that's going to be those things we take into account. And then the other factor is those people in the back we call passengers. We look at their trajectories for these aircraft, and I always say if you're gonna give somebody a limo ride, you're advertising a limo ride, but you delivered a carnival ride, they may not want to get back on. So when we look at their trajectory, we're looking for a nice, smooth approach, a nice, smooth departure, not a lot of interruptions and turbulence. And there's a lot of good data in the aviation world that speaks to horizontal G-loading on people and what their tolerance is. In aviation, there's not a lot of good information on vertical. So the one group that I looked at that has a lot of fantastic information on what the G-loading tolerance is on a person is the elevator industry. And they all say they don't care how fast they go, but they do care how fast you accelerate them to that point or decelerate them from that point. So it's interesting. You can't just snap your fingers and be there. It's not something people in the back are going to put up with, I don't think. And you don't want to vomit comet.
You know, that's interesting. If you have to come in hard and fast or come in, stop, hover, it's going to be a completely, I never thought about that, the experience for the passengers.
Well, the other one that we talk to a lot of times is we say, everybody's about EVTOLs being quieter than a helicopter. So one thing the helicopter's got going for it based on its normal approach is the noise that it does create is transitory. It comes, it's there, it goes. If you're hovering down and you have to go a certain rate because you are susceptible in an EVTOL to vortex ring state. So you can't go too fast. So that means you have to, go at a certain rate.
What's vortex ring state, Rex? Help me with that one.
No, in a helicopter, if you think about it, the aircraft is turning a rotor that is basically cutting a slice of air every time it turns. And that slice of air then becomes downwash. And that downwash comes off the rotor. In flight, that downwash becomes a wake, also like wake turbulence in an airliner, but it's a wake. But once you go below what we refer to as effective transitional lift, or EVTOL, ETL. God, I can't remember all this acronyms we use. So you go below effective translational lift, which is roughly somewhere between 17 and 20 knots. All of a sudden that wake becomes downwash. Well, if you go too slow
And you're descending into the downwash.
you start to descend into that downwash, the helicopters have a tendency to take that and recirculate that downwash. So if this is the tip of your rotor blade, downwash comes down, comes out, and gets recirculated. And
I'm guessing you're losing lift when that happens.
that starts to migrate inboard towards the center of the aircraft. So it's actually stalling that tip. What happens when we teach new pilots settling with power, we take them out at altitude, and you need three things. You need near zero to near zero airspeed, you need power applied, and a descent rate. And once you get into it, if you start to pull up on the collective, the one thing that you don't want to do, because it exacerbates it, it actually accelerates that situation. The rule of thumb is directional flight. Get out of it so you're in clean air and you're not getting that recirculation. If you type in Vortex ring Satan drone into YouTube, you'll find a lot of people who have experienced it and didn't know what it was until after it happened. Because what they did was the cardinal sin. They added power to get out of it, and all they did was accelerate into the ground faster. So given the altitudes we're talking about and coming straight down, if we do it too fast, this aircraft being susceptible to vortex ring state could get into a situation that if the pilot reacted improperly, one, add power, he could exacerbate the situation and get a vertical descent rate that he couldn't recover from. And two, based on the design of this airspace, they don't have a whole lot of room to maneuver.
I remember when they taught us the concept when I was a Navy pilot landing on carriers, but you get behind the power curve.
Exactly.
When you get slow enough and you have so much drag on that airplane, even at full power, you are not going to recover. You're going to head straight down into the back of the ship or the water. Even in full afterburner, you can get to a point where it's uncontrollable. So you have to anticipate those. And what you're talking about is creating designs of vertiports and heliports so that that effect is minimized as much as possible, correct?
Exactly. And the other piece of that puzzle is we take into account what the prevailing winds are at in that location. So we always want to make sure that the pilot or the aircraft is flying into the wind whenever possible.
Would that require like a data study for a period of time?
It could.
Right?
Yeah, it could. There's a lot of data out there that you can pull from of current weather at AWOS and ASOS stations. Are all recorded. So I can go and pull that data and tell you what the prevailing winds are in a particular location. If there's no data to be had, if there's an airport nearby, that's say a small airport, look to see what direction the runways are lined up, because they're usually lining those up with the prevailing winds. Look at other data. Sometimes I did a big study in downtown Chicago, and they actually put weather recording systems in place and recorded the winds for 2 years before we put the heliport in, just so we knew exactly what the approach departure paths should look like.
Yeah. Well, this is fascinating. So in addition to those, what are some of the other challenges of rolling out either, AAM or VTOL infrastructure?
I think one of the big ones that you have to point to is the electrical grid and the electrical health. Airports have electricity. Now, whether they have the capacity that's available to support a charging system is the question. And moving electricity on an airport isn't as easy as you would think, because most of it has to be buried. And there are certain locations in an airport, they really don't want you digging. So getting the electrical supply is huge. And then does the grid have the capacity and the excess capacity to support what you're looking for? Heliports, if you're looking to modify a heliport, the average heliport doesn't have electrical power. If it does, it generally has 110 volts that run the lights, not nearly enough to run a charging system. So then we look at...
Yeah, what is the voltage you need? Like I have a Tesla, so I have a 220 volt circuit in my garage, but I go to a supercharger, and it's literally 10 times faster than my 220 volts, so I don't even know what the voltage they're running at, or the amperage is actually probably a better measure, but it is significant.
No, it's one of the things I've had some work when I worked with Uber since then. I work with a company called ChargePoint and asked that I was like, what am I looking at here? So they work in the measurement of wattage. So we have kilowatts and megawatts. So we looked at, I said, well, how many watts do I need? I said, well, we're expecting our chargers to be somewhere between 500 and 600 kilowatts. I said, well, that's pretty significant. I said, so if I were to put or let's say 10 of those chargers in at a location that are 500 kilowatts, all of a sudden I have 5 megawatts of energy. I said, that's a significant impact on any neighborhood, any grid. So when we look at moving power, that's the big expensive part. So you say, hey, I want to put these chargers in. I got to get power here. So 2 studies that we looked at, or I've looked at specifically and talked to the people that did them, it's somewhere between $500,000 to $1 million a mile to move that power. Now, once you move the power, that's only one piece of the puzzle. You're probably going to have to put in a substation. And the only thing I found that people hate more than heliports is substations. It's a lot of people are very passionate about keeping those out of their backyard. But substations, on average, take about 2 years to go through the permitting process. And then once you're done with that and you start building, it takes about another 2 years to build it. Copy or factor in a challenge you have based on all the natural disasters we've had around the world, specifically fires and hurricanes and such. The demand for power grid equipment, like the type that goes into these substations, they're on back order 18 to 24 months. So it's hard to go to an investor and say, hey, I'm going to put in a vertiport. Well, it's going to be 5 years before we can open it because it's going to take that long to get the electricity there. So that's, I think, a big challenge when we look at building greenfield, even brownfield. When you look at putting this in an airport, one of the biggest things that you need to do is, okay, where's access and what's the capacity of access? And if I don't have it, how long is it going to take and what's that look like in the future? So I have a feeling that phase 1 may have 1 charger. Phase 2, you may see 3 chargers at 3 years. And then phase 3 at say 5 to 10 years, you may have more chargers.
You know, it's interesting. So just put this in context, because I got a hybrid car now too also. And most of the charge point chargers are 100 kilowatts. So a 500 kilowatt charger is like 5 of those, because you need that to charge an EVTOL in time to make it usable again.
Right.
But I'm also thinking about this, right? A 50 watt bulb, I need enough power to light up 10,000 50 watt bulbs. That's what 500 kilowatts is.
Yep.
So think about the piping and the power and the amps that are flowing into just one charger. And then I want to be able to charge 4, 5, 6 EVTOLs if I'm going to have a vertiport that actually is more than just single use.
Well, and that's the thing.
Am I thinking about it accurately?
No, you're looking at it just right, because you look at the business model. Business model is all about throughput. The faster you can turn people around, the more money you can actually make, to a point where you can break even and then make actual profit. One of the big keys is being able to charge as many aircraft as possible, as quickly as possible. So fast charging, however, comes with several challenges. Power grid, power availability is one. Working to develop a battery that doesn't have susceptible damage to it because of fast charging, dissipating the heat that's generated during fast charging. Being able to put a cable on an aircraft that is capable of delivering that level of power without being unsafe. Now we're talking significant amount of weight because of the copper. I think there was a documentary that Al Jazeera did on green energy as I think it was a darker side of green. One of the comments in there that I looked at was a gentleman said that the amount of copper that the human race will need to mine over the next 30 years to support electric vehicles and advanced air mobility is equal to the amount of copper the human race has mined since it was a human race.
Wow.
I was like, well, that's quite a bit.
Yeah, there's not an alternative to copper that I'm aware of.
If there is, it may not be as good. I know aluminum, you can get electricity through it, but it's not as good. It's not been proven to be as good, if you will, as copper in that space. I know the group that I've talked to a lot that has some really good things to say about the electrical grid, the electrical capacities and things like that is NREL, National Renewable Energy Laboratories out of Colorado. They've published some fantastic papers on electrification for airports. So if anybody has any questions, I'd point them in that direction.
Is our grid capable of this increased load?
Yes and no. Some places probably yes. Newer places, yeah. But just like you have a charger for a Tesla, you bought the fast charger. If you'd have went home and then discovered, oh wow, I've only got a 100 amp breaker box, you would have now be on the hook to put in a 200 amp breaker box.
Well, I actually did. I had to pay an electrician to come out
There you go.
and completely put in a whole new separate box and then
Yep.
run that separate line. And we
Yep.
had to get permission through Excel Energy, and we had to, but it was worth it
Yep.
because I could charge in my garage. But
Yep.
I mean, just at my house, that was a pretty meaningful expense.
Exactly. So there's a lot of homes that only have a 100 amp box. So if all of a sudden, say, 7 or 8 of your close neighbors decide to do the same thing and they experience the same problem, that infrastructure upstream is probably as old. Now all of a sudden the infrastructure upstream may not be able to support what you are now drawing as a community. So
Is
those are
that why
things
our power kept going out in the neighborhood? Now I figured it out. My neighbor got a Tesla too.
there you go. But those are questions you have to look at.
It is.
Yeah, it's one of the things is can the grid support this added drain? One of the things when I was working for Uber, they sent me down to Los Angeles to look at different locations. And while I was there, it was 110 in the shade. I was down there for about a week and a half looking at all the different locations, and they kept having brownouts because of the demand on the grid already. And that was one of the things I was thinking. It's like, so you came into the city in the morning when it was cool and there was no problem. Now you want to go home in the afternoon when it's really, really hot and there's no power to recharge. How do we deal with that? And in talking with a lot of the people in the space, they said, well, what we can do is actually put on-site battery systems in, electric storage systems or ESS. That is something you can charge at night when the demand is lower. And then when the demand is really, really high, this can augment your power system so that you can charge from it. Now that's a big footprint, but
Well, they're also expensive and they're heavy.
and they're heavy.
And I'm thinking about, a lot of this, like I envision a lot of this being retrofitted onto rooftops, stadiums, buildings, maybe a hospital that wants to expand their capacity. But now we're talking about the cabling, the wiring, the copper, power wall, fire suppression systems. Because if you have a lithium battery fire on top of any of these buildings, that is no bueno. So what is the feasibility of these kind of vertiports off of ground level?
And that is a huge challenge. Every fire inspector and fire marshal I've talked to is not too keen on lithium ion batteries on top of their buildings. And I work very closely with the National Fire Protection Association. I sit on the committee that writes fire standards for heliports. Now we just did, NFPA just did publish a new standard that's heliports and vertiports. And we just kicked off the next iteration of the next revision this month, which is a 3-year process that will, update that. But in looking at the fire standards, there are fire standards for electric vehicles. 855, NFPA 855 is the electric storage system. There's also one for even hydrogen. So NFPA 2 is a hydrogen standard. Then you look at the electrical code, NFPA 70. You also have healthcare has NFPA 99. We have 418. There's 407 and 409. So you have hangars and fuel systems. So there's a lot of guidance out there. And the one that just did change quite a bit and has updated is for parking garages. I want to say that's NFPA. I'll get it wrong. I want to say it's 82. I can't remember specifically. But they've been having a lot of issues in certain parts of the world with EVs and parking garages. And if you look at what's on the internet, what's one of the areas everybody's looking to put a vertiport? It's on top of a parking garage.
Yeah, it makes a lot of sense.
Yeah. No, I would agree. And
Centrally located, people are already, commuting in and out of there. There's a big open flat roof.
yeah.
It could support the weight, I'm guessing.
There's a key difference that you have to pay attention to. It's not impossible. So when we look at a parking garage, you have to take into account two things for the aircraft. They only really take into account one thing for cars, and that's the load factor. So for a car, you take in the static load. For an aircraft, you take in the static load, but you also have to take into account dynamic load. And the way the FAA and the architect design guides speak to that is you take whatever the max takeoff weight is, multiply it by 1.5 or 150%. So if you had a 10,000 pound aircraft, the dynamic load would be 15,000 pounds. So one of the things you have to look at when you're working on a parking garage is the International Code Council specifically says it's rated at 40 PSF. Heliports for helicopters above 3,000 pounds must be rated at 60 PSF. So you have
And what
to
is
figure out
PSF? Pounds per
pounds
square
per square
foot?
foot.
Right? And
Yep.
that's one of my construction standards. So I might not have met the construction standard, so it might even be an option for me.
So you can either put something,
retrofit.
yeah, retrofit, put something down on top of that that disperses the load. So augment that by putting in a different layer that spreads that load out properly. Get some construction in, or as you said, build an additional level. Now, most parking garages are designed and overbuilt. A lot of them are designed for multiple stories that they never use. And I found when I was in LA, the average person doesn't park on the top because of the sun.
Right.
So if you put another level, all of a sudden now you've got more people parking in the parking garage. So it's a win-win.
Now, something that the FAA came out recently with their concerns for heliport design is downwash and outwash, right? And it kind of relates back to our conversation recently about just getting stuck in your own downwash. But some of these could be more significant than helicopters. But you're the expert, so I've been wanting to ask you your thoughts on this and how this could impact vertiport design. Because the average helicopter standard is what, 50 by 50 feet?
It depends on the size of the aircraft. I would say the design helicopter dictates the size of the heliport. So if it's a small helicopter, it's going to be a smaller. If it's a large, heavy helicopter, the heliport's going to be bigger. Now, having done the research and looked at all the heliports in the United States, I went through and did the data mining of the 61 plus 100 heliports that are on record. I can tell you right now the data is terrible. And we don't know exactly how big the heliports are because it's incorrect. That said, the majority of the heliports in the United States happen to be at hospitals. The Heliport Design Advisor Circular the FAA publishes says that the smallest heliport for a hospital is 40 feet by 40 feet. So all the hospitals, in essence, put in 40 by 40 pads in a lot of cases. So the average size is probably 40 by 40 or less. I put in several heliports that support larger helicopters, even up to the S-92, which is the new presidential helicopter. That then requires basically a 60-foot by 60-foot touchdown and liftoff area, surrounded by a final approach and takeoff area that's about 102 feet. I think the safety area is 145 feet. Now, when the FAA looked at EVTOLs versus helicopters, they also looked at the accuracy of the aircraft in landing and taking off, and I think that's why, if you look at the Engineering Brief 105, they're still using a slightly larger TLOF than what we use for heliports, a slightly larger FATO than we use for heliports.
What's TLOF and FATO, Rex?
Sorry about that.
That's
Acronyms
okay.
of my life. Acronyms. So TLOF is touchdown lift off area. That's the physical structure that the aircraft is touching down and landing on. That could be concrete, that could be aluminum, that could even be grass.
Okay.
FATO, final approach and takeoff area, is the maneuver area. That's the area that you want to keep clear of obstructions. The other term that is
And I'm guessing
used,
that's circular around maybe the center of the heliport, correct?
well, the maneuver, if your TLOF is square, your FATO should be square. If your TLOF is round, your FATO should be round. So the two should mimic the shape.
Okay.
But the other term that is used is out of the Code of Federal Regulations. When you talk about airspace, they use a term called imaginary surface. So you have the transitional surface, you have the approach surface, and then you have what they call the primary surface. The primary surface and the FATO are two totally different things that occupy the exact same space. But it's a regulation, whereas TLOF is defined and only defined in an advisory circular. And then outside of that FATO, you have what we call the safety area. That's our fudge factor. So if the pilot finds himself outside of this FATO, he's got a safe environment. So if he has an engine failure, has tail rotor effectiveness issues, or has tail rotor failure, or really bad windy, gusty day, and he's not able to keep it inside the FATO, he's not going to run into something right outside the FATO. And that's one of the issues we see in a lot of the illustrations that people are putting out online for vertiports, is no one's taken into account all those imaginary surfaces for safety.
They're just drawing the square 40 by 40 foot box and going, we can put that right there, or 50 by 50, right? Because you don't think about these other things when you're maybe an architecture major, or even myself going, hey, you could put a pad there.
No, there's a lot of, there's some really cool animations and artist renditions of vertiports on the internet that I wouldn't give you a plug nickel for.
You know, it's interesting too, you know, anybody designing an aircraft, if you want to use it for the EMS mission, you have to take into account a majority of our customers in that world, we have to be able to land on a 40 by 40 foot pad or require our customers to retrofit, which is going to be expensive. So these are serious design considerations for manufacturers.
Right. Yeah, and that's a good question, because we look at all the hospital heliports in the United States, and I would say a large majority of those are 40 by 40. Now, if it's a ground-based pad, you know, retrofitting that and expanding it to what we need for an EVTOL is probably not going to be too terrible.
Well, if it's in the backyard of the hospital versus the roof, right?
Exactly. But if it's a concrete pad on a roof and it's only 40 by 40, yeah, the expense to do that's got to be significant. So that may be one of the hindrances down the road because of the size of the aircraft. And I think one of the things that is another stumbling block for everybody is the fact that in the helicopter world, the touchdown liftoff area is the load-bearing surface. The FATO, the final approach and takeoff area, it can be load-bearing, but it doesn't have to be. You look at the engineering brief, the FAA said, well, the FATO, the final approach, has to be load-bearing. Well, that increases your surface area significantly. So if you had a 50-foot controlling dimension for the aircraft, now you're talking a 100-foot by 100-foot load-bearing capable structure. And if you look at all the hospitals, then you're lucky to have a 40 by 40 right now, and you probably don't have the real estate for that 100 by 100. So that in itself is going to be a challenge.
Now, so let's kind of switch gears. I want to ask you a couple questions here before we wrap up. And
sure.
I was thinking about VFR versus IFR operations. We were talking about a little of this before we even got started, is how does the VFR requirement today affect infrastructure, and what is going to have to happen to allow IFR operations?
I don't think there's going to be any restrictions on the VFR piece. We've done that for a long, long time. We know what that looks like. We know what the weather we need to accomplish that. It's the IFR is going to be a little bit more of a challenge in that we just did, with the release of the latest advisory circular, which is 2 Delta in 2023, actually put some documentation in print that speaks to what that might require. Because up until that point, we didn't have a minimum criteria for what survey data needed to look like. Now we do, but to be able to, depends on what kind of IFR operations you want. So today we're doing point and space approaches, pins approaches to heliports. Now that doesn't mean we have any IFR heliports. We have VFR heliports with IFR procedures attached to them. And you have two different types, basically. You have proceed VFR. So you break out and you go to the heliport under VFR conditions. Or you have LPV, proceed visually, meaning you have to have
define LPV, would you, Rex?
No, don't ask me to do that one.
I know I fly LPV approaches and I don't know it either, but okay, so press on.
So the key there is proceed visual.
Right, yep.
You have to be able to see the landing environment. Some portion of that you have to be able to physical, or you have to do the missed approach. Now, The average pins approaches that are out there today are going to get you down to a height of somewhere around 250 feet, plus or minus, depending on other factors. An ILS at an airport is going to get you to about 200 feet. It's not until you get into really big iron do you see Cat 1, 2, and 3 where you can get down to the actual runway.
Yep.
Now, to do that, it is possible. The problem is finding somebody willing to spend that kind of money, and also having the footprint necessary to support it, because now you have to have a certain type of lighting, which takes up a huge amount of real estate, and you need a certain type of equipment to be able to pull that off. I don't know. It's like we could do IFR, point in space approaches, without too much of a challenge. We have that technology today. We can move that. But if you want to get lower, you want to do actual full touchdowns to a heliport, who's going to pay for that, and what's the return in your investment? That's a challenge.
I hadn't thought about that. For an instrument approach into an airport, all the lighting systems that are just so commonplace. But now you're talking about anything past VFR, you're going to need those kind of lighting systems incorporated into the vertiports, into the helipads, if you want to do any kind of IFR operations, which for some instances is a requirement. And something you mentioned, like in LA, 25% of the days are IFR because of smog, fog, smoke, clouds. But think about that. You have if you're not flying IFR, you have a 1 in 4 chance of getting canceled if you're using a VFR only service.
There's that potential. Yep.
That's anything else as this rolls out. There's going to be a lot of things around the community, regulations, technology. We talked about earlier, but gaps in just weather reporting. There's a lot of issues. Is there anything else that you're seeing right now, maybe as we wrap up, just final thoughts on what are the biggest priorities that you have, all the committees you have visibility to really focus on over just the next year in particular?
I think one of the key elements that I've been pushing for the last couple of years in this space is harmonization. And when I say harmonization of regulations, not only in the FAA, so there's several different parts within the Code of Federal Regulations that we need to make sure say the same thing. And we can't, point to all the different regulations and find that today. So there needs to be harmonization internal, but there also needs to be harmonization amongst fire code, building code, regulations. And then we take that aviation world and turn it into the planning and zoning at the local municipality side. And you almost need a Rosetta Stone when you get aviators and zoning and planning people together, because they don't speak the same language. And working in that environment for 30 years, it's interesting when clients run afoul of something. It's usually the planning and zoning. And part of that is education. So
and that can put a rapid stop to anything.
Well, yeah.
And you don't want to get sideways with those committees either.
No, and I've had several clients do that. If you're going to put a heliport in, there's 3 levels in the U.S. There's federal, state, and local. Local's the hardest. Federal's the easiest. Here's your checklist. Follow it. File your paperwork. State's usually a little bit harder, but not terrible. Here's your checklist. Oh, by the way, we have these additional requirements. Call us. We'll help you. But the local level, that's the challenge, because a lot of times you have to go in front of planning and zoning meetings and hearings where all your friends and neighbors get to attend and sharpshoot you for trying to put a heliport in the backyard. I always tell clients, I said, don't let them find out about your project in the news. Go talk to them one-on-one, explain it to what you want to do, why you want to do it, and help educate them. Same with planning and zoning commissions, as well as city councils. A lot of these people don't get education in aviation. They don't know what a TLOF and a FADO or a safety area are. They may have an ordinance on the books. They may not have an ordinance on the books.
Well, and they're also afraid of the community getting the wrong idea and everybody now complaining that this is going to ruin my neighborhood because of noise.
Exactly.
Or I don't want somebody crashing in my pool.
Exactly. Safety and noise are the 2 killers of heliports today. And to say that EVTOLs are silent is a lie. They do make noise. How much noise, we don't know. And the other side of that coin is what kind of noise. So we measure noise using a decibel rating with a day-night level, and it may meet that. because it's quieter. However, what's the frequency, tone, and the tenor? It may be like nails on a chalkboard to some people. Australia had that. You go to YouTube, type in Australia, drone, and noisy neighbor. And there's one neighbor who says, hey, this is great. I can order a cup of coffee or a hamburger anytime I want. The other neighbor's like, oh, this is terrible. He's ordering hamburgers every freaking 5 minutes, and it's like a herd of bees going by my house every 10 minutes. Depends on who you are. So that's one of those things we look at when we talk about noise is what's it sound like? And that was, I think, Amazon, I heard stories of they ran into that problem with their design because the rotors were small, high frequency, and it just irritated the heck out of everybody, though it met the level. So that's an issue that we need to grapple with is what are the metrics that we need for measuring the noise? And that's going to take some research and development in that space. There's a lot of research. Weather's another one we talked about early on. That's one that we need a lot more research in. We need some more dollars in. And I was very happy to see AS Team International get some documentation put together on what third-party systems are going to look like, because policy has always been based on technology in the 1950s. Policy was written in the 70s. So we need to fix the policy to match technology. And that's always been the challenge in this space. Technology is always outpacing policy. So working on Capitol Hill, I can tell you that's also a big challenge. And getting the right players in, giving the right education. And that's one of the things I know Mike Hirschberg and now Angelo Collins and myself have been on Capitol Hill trying to provide our congressmen, senators, and everybody else up there the right information, the correct information to make better decisions.
Yeah.
So,
well, that's important work. So as we wrap up, Rex, this has been fascinating conversation. What just final thoughts do you have to leave with everybody as they've been listening in?
no, it's one of those situations that's changing daily. I said, the good thing, like I said, in the Vertiport standards world, there is a standard. NFPA 14 is published. You can go read that for free online. The advisory circular that the helicopter world uses for heliports is online. It's a free download. Now that vertiports are going to be a class of heliports, I would highly recommend you go look and see what's in that heliport design advisory circular, because that's going to be a lot of the same thing that we use for vertiports. There's a lot of good stuff coming out of NASA right now for educational materials, so look for that as well. There's several different groups that meet. I'm involved in the infrastructure group that meets on a regular basis, and we look at all the different opportunities for the research side. Vertical Flight Society has put on several workshops that I've helped spearhead for infrastructure over the last 5 years. The other group, VAI, Vertical Aviation International, now, or used to be Helicopter Association, heavily involved in the advanced air mobility world. So is GAMA, General Aircraft Manufacturers Association. Even NASAO, the National Association of State Aviation Officers, has an advanced air mobility group. So everybody's pulling in the same direction. We just need to all get together and make sure that we're all singing off the same hymnal when we do so.
Yeah. Well, this has been great. I really appreciate you going into the detail you did. You're such an expert. I know we're going to want to have you back on, Rex. So let's reserve that down the road as we solve some more problems and maybe source even some more questions. Every time you solve a problem, then you got the next one to solve. So love to have you on. So, man, great getting to know you. Keep knocking them alive out there. I look forward to our next conversation.
Thank you for having me. Greatly appreciate it. And I look forward to the next meeting.
Me too.